Welcome back to AutoTechNick, and today we're going to be working through a comprehensive vehicle inspection on this 1990 Ferrari 348 TS. So I've been looking forward to the day where we get some 348 content on the channel, and what a great example we have here with this 1990 TS. Now, we all know that I have a lot of 355 content on the channel and really a lot of good in-depth videos covering that car. And well, the 348, it's essentially the same chassis, very different engine, gearbox, very similar but yet different. So these cars share a lot of the same things, although they are still very different from one another. And it'll be very good to have this car here so we can talk about some of those differences and also just kind of shed a little bit of light here on the 348, because I do dearly love these cars and they do not get the attention that they deserve. Now, this particular 348 came to the shop because the owner plans to sell the car. And he knows that it's well past due on a major service or a timing belt service. I think it's pushing 10 plus years. And he is trying to decide if he wants to do the timing belt service and then sell the car, or sell the car as is without a timing belt service done. Because what we ended up deciding on is, I said, hey, I normally do this inspection process as part of the timing belt service. I run through, it's comprehensive. You guys have seen it on my 355 videos. So I drop the car off, I'll run through and do that full inspection. You and I can then sit down, decide what is the best path forward on the car, on you maximizing your return on investment and getting the car sold and serviced based on the condition. And I said, I do this inspection anyway, so if you decide to do a major service, we'll just move on and start doing the major service. If not, I'll just charge you for my normal PPI plus compression inspection, and you can sell the car as is. Where I'm going with that is, we know we're going to be doing this video doing the inspection on the car, but we don't know really what our scope of work is going to be long term. Maybe we're going to get more content. I would really love to do a major service on the car and get that content for you guys. So we will see, but we won't know until we get the car inspected to find out what kind of condition it's in to make that decision. I'm going to start off doing my normal pre-service drive check. We're going to check our tires, check all of our lights, the stuff around the car, make sure the car is safe and operable to drive on the road. This car has been sitting a very long time. And then I'm gonna get some cameras on the car. We're gonna hop in it, take it for a road test and get it evaluated. So one thing on this particular car, since I know it's been 10-ish years, if not maybe more, since it's had a major, and when I check the tires, it's on 12-year-old tires, more so because of the timing belts. We're gonna take it pretty moderate and easy on this test drive and evaluation. It's just, when I get these cars that have such deferred maintenance, it's not really worth the risks for me to really put that engine under that much stress, potentially have something go wrong while it's under my care. I do like to take the cars out, be able to run them full throttle through the gears, make sure they're running good and power delivery is good and that the clutch isn't slipping. But this is one of the few instances where I'm gonna err on the side of caution and not do that, just because of the amount of time this belt has been on this engine. And I also think in this particular car's case, I don't think it's seen all but a couple hundred miles in that time. So that belt has been sitting almost in the same position for 10 years. We're definitely gonna take it easy, short, quick drive, make sure everything's working. And we got our AC going right now. And it's not, I can tell you, it's not doing a whole lot of AC-ing. Checking my dash vent, 83 degrees. So there's something there we're gonna have to look into at the AC. But even though we can't run the car through the gears, we can still run it through, evaluate the clutch engagement, which actually it feels really strong. It's actually pretty abrupt. And the client did send me an email that he had with some information about the car. I glanced over it. I think I remember seeing something about a clutch in there and what they've done. He also gave me a bunch of spare parts that he had with the car, and there's 2 clutch discs in there. So we might need to look into it a little further. It almost feels like it doesn't have the dual mass flywheel anymore is the best way to describe it. The clutch engagement's very abrupt and firm. It's very good and strong. It just doesn't have that soft easiness. And also I've heard not an ounce of flywheel rattle or chatter from this car, which lets me think that there's something non-OEM back there. So it looks like it's going to be a no-go on our AC. Unfortunate. And as much as I don't want to, we need to test the heat. And what a day. What an absolutely gorgeous day to taking this car out. And a much needed day for us here in Seattle. Springtime here, man, you have to earn that. These nice glorious days. It's probably 75 degrees, no wind, no clouds, everything's green. Absolutely love it. So I noticed that the car's done that twice. When I've put it in neutral coming to a stop, the engine surges up to about 1500 RPM, then came back down to 1000 on its own. And oh my gosh, the heat is working. We don't need that. Whew, it was blowing 130 degrees out the vents. That was too warm. Yeah, the RPM was surging up, so I don't know what was causing that. I just looked over. Actually, my floor mat is kind of on the gas pedal. Moved that over and my foot was kind of hitting the gas pedal. These cars have real little pedal boxes. And I'm also wearing boots, which these are the smallest boots I can wear and still drive these cars. A lot of times I'd actually just change shoes before I have to drive them. It's just real tough. So 348s, like we mentioned, they're real similar to a 355, or I guess we should say a 355 is very similar to a 348. It's essentially the same chassis. A lot of the components, the doors, all the mechanical bits of the car is the same. Control arm suspension, roughly the same. You know, they really updated the 348 later in its production, and the 355 is really built to fix a lot of the shortcomings of the 348s. Biggest difference between a 355 and a 348 is the engine. So the 348 is using a derivative of the 328 engine, so it's a 4-valve engine. It does not have independent throttle bodies. It's mechanical lifters, not hydraulic lifters. 355 and the 360 are the only cars that use that base engine, and that's a 5-valve engine, individual throttle bodies. It's a very, very different engine. You know, 348's about 300 horsepower, 355's 380, so it's a big jump up when you get to a 355. There's quite a bit of changes on the body. They're really subtle, but the rear hips and fenders, everything's just kind of amplified and accentuated a little bit more, so they have very different lines. But it's not all about the 355. There's 2 main features of the 348 that I absolutely adore. One of them, 348s have manual steering, and I'm here for that. I know that some 355s supposedly were optioned where you could have bought them with manual steering. I have never seen one. Never seen one online and never seen one in real life. I've only seen the options in the parts diagram. Now, another feature on the 348 that is much different to a 355, and it's one of my other favorite features of these cars, is our transmission. 355 is 6-speed, 348 is a 5-speed, but a 348 is a dogleg transmission, meaning my first gear is down where second would normally be. My reverse is up where first would be. It's up and over. So right now, I'm all the way back and to the rear. I'm in first gear. I love these transmissions. It just adds a little bit of element of uniqueness to these cars. It's honestly not that bad to drive them and remember what gear you're in and kind of adapt to it with a different pattern. And it's just a unique feature. Only a handful of Ferraris have a dogleg gearbox, and in between that and the manual steering, absolutely love them. Well guys, we're having some issues with our cameras. Unfortunately, it's the one tied to my microphone. It gave me a warning that was overheating, so let's hope and pray that these cameras make it through the test drive and that we don't lose audio. And it looks like we're not going anywhere quick at all today. Man, really fighting this camera. Keeps shutting off. But finally got out a little bit of traffic. You know, there's a little bit of vibration in the steering wheel I can see here. Certainly from the car sitting so long. We got old tires. I felt them. They felt like a brick. But it's driving good. We're in 5th gear. Good oil pressure. Coolant temp is good. All of our gauges are good. Driving pretty good. Happy with it so far. It's tracking true and straight. Not too bad. Oh yeah, there's a lot of vibration there. Now 348s, I'll say that they have one of the most unique engine notes out of all the Ferraris that I've heard. The best way I could describe it is it's like a gurgly or burbly sound. It's very different than the 328, which this engine is essentially based off of. You know, it's a modified or an evolution, a modified version or an evolution of the 328 engine. But unfortunately, they do not have the sound that a 355 has. And as much as I do love 348s, you cannot argue against or beat the sound of a 355, especially with a Custode exhaust. It is just, that's peak Ferrari. It is peak V8 Ferrari. Not many cars get better than those, period. Well, we're back, and it's been about a week since we did our road test and initial evaluation on our 348. After the road test, I was able to look over the car, get most of my stuff documented, looked at, the suspension shaken down, and get a really good idea of the condition of the car, but I fell just short of my goal of getting all my items completed on the inspection. I had a trip to make. I've been gone for about a week. We're back, and today we're going to finish up those loose ends. And these are really the key items. They're like the really big, important items that I like to do on these inspections, where I kind of view they're above and beyond what most inspections are, but they're real key and critical on evaluating the overall condition and health of the car. So, since the car has been sitting here and it is cold, the first thing we're going to do is take advantage of the cold engine, and we're going to be smoke testing our exhaust manifolds or headers. I have my smoke machine hooked up over there. This one operates off of compressed air. It's hooked up to our battery here, and then we have our supply hose that is running in, and I think I can get you guys down there. Hopefully you can see where it's hooked on to that nipple right for our non-return valve for our secondary air. So we have that hooked up, and then that's going to emit the smoke into the exhaust manifold, fill it up, and we're looking for any smoke coming up in the engine bay for any cracks or failures of the manifolds. Now, to keep our smoke from coming out of the tailpipes, just a couple old dirty rags stuffed in there does the trick. That does just what we're looking for. I will say that oftentimes you're going to see a little bit of smoke whisking out of maybe where the catalytic converters bolt up, or some of the joints rear on the exhaust towards the rear by the muffler, and those aren't as critical when we see leaks from there. Obviously it's not ideal, but that's not really what we're looking for. Obviously, if there's any leak in front of the O2 sensor, that is a problem. And if it's a car that has rear O2 sensors, not that critical. It's always the front O2 sensor. So we need to be sure that there is 0 leaks from the heads to the front O2 sensor. That's the main thing that we're looking for. I say that because if there's a leak in between the head and the front O2 sensor, that's where the manifolds or the engine can actually pull air in, atmospheric air in, and then the O2 sensor reads a too lean of a signal, and then that just starts causing the ECU to put more fuel in when it's already running just fine. Then it actually starts running rich. It kind of just throws the ECU in a weird failure state, and it's because it's getting a inaccurate signal from the O2 sensors. The main objective here is to test the integrity of the headers. So since we have everything hooked up and we're ready to go, I'm gonna come down here, turn on my machine, turn on my flow and my smoke, and then we're going to come up here and just kind of keep an eye and look for any smoke whisking out, coming out of here. And we have the coolant expansion tank that's a little bit in our way. But I'll give it a couple minutes to let everything fill up to make sure it's not leaking. Like I can say down here, we just want to be sure that there's no leaks coming up in front of the O2 sensor there. Now this car doesn't have any cats. It goes right to the muffler. And all these gaskets look relatively new, so I don't expect we're going to find anything. It's not often that we do find something with the smoke test. Obviously, the more common cars with failed manifolds are 430s and 355s. However, I've seen virtually every model of Ferrari, relatively modern Ferrari, have a failed manifold at one point or another. And for example, the 575 behind me, it's in for a PPI, and I found a failed manifold on the right-hand side rear of the engine. Just a small amount of smoke whisking up, but that's all it takes sometimes. And depending on the manifold failure type, sometimes they're repairable, sometimes they're not. It really depends if it's just a cracked weld or if there's actually a lot of degradation from the metal in the manifold itself. Where I've had one where I cut a 355 manifold apart after it failed, and it was completely falling apart. All the metal was just so fatigued and it's like work hardened over time and cracking that you would have to basically replace everything. You couldn't just weld it up. I will say, from getting the heat shielding off on that 355 manifold, that was much more of an event than I was anticipating. So it's one of those things when you get it there, the cost of replacing it versus repairing it, you really have to take those into consideration because it is a lot of effort to get in there and repair it. And a lot of times you invest the time to get in to see if you can repair it, and you cannot repair it. And then you're out money for the time spent trying to find out if you're repairing it, and then you still have to end up replacing it. As I rambled on about that, that should have given us enough time here to let some smoke starting to get into there. Let's pull our hose off and make sure that we actually have smoke going here. We don't. Well, that'll probably help. Well, that explains that. So we had our valve off for our air. So now we're going to come back over and we'll just confirm that we have smoke. Yeah, and there you go. You can see that. So we'll shut this off real quick so we can get it hooked back up. All right, let's try this again. Our red light is on, meaning we're flowing smoke. So then we'll come back up here and try to keep a light so we can see what's going on. There we go. And a lot of times I'll just use the flashlight and I'll just kind of shine around because the smoke that's emitting can be really faint sometimes. It's not just a, egregious amount of smoke that's coming up. Sometimes you're just looking for little whisks and whispers of it. And it's really hard to tell because the way these headers are, the manifolds, you can probably see easier over here. There's a very large one-piece heat shield over the whole thing. So even if you have a failed primary in the middle, the smoke has to work its way to the edges of that heat shield to come out. So we'll give it some time, and you can see right there, I just ran my light over that, and I hope that shows up on camera. We have a bunch of smoke back here, and that's all right down there on that joint that I was talking about. So that is leaking before our O2 sensor, which is not ideal. And those gaskets do look pretty good. So we will note that. And we would definitely want to be able to fix that if we could, but right now our primary focus is checking the integrity of this manifold. I see a little smoke to the side. I have to look and see if I can find the source of that.
Sometimes the smoke just kind of works its way around, so you have to tell, is the smoke I'm seeing right up there coming from back here, or is it a source up on the manifold? So it takes a little looking and figuring to see exactly the source. Sometimes, like you can see, there's a little bit coming out where my hose is up on the port. That's normal too, just not an ideal fit. I see some smoke right there. Well, I'm gonna keep looking at this and evaluate it. If I determine that this header has a leak, I'll bring you guys back and show you. Otherwise, we're gonna assume that it's good and then move on to the left side. So I made the determination that our right-hand manifold is good. All the smoke that I saw coming was coming from the cat test pipe to the header connection from that gasket. Maybe it just needs to be tightened. I mean, we'd have to investigate it a little further to find the exact cause, but our point was to see if our manifold was good, and it was. And I did already move everything over to our left-hand side, but I brought up a good talking point that I've actually talked about in previous videos when I'm talking about smoke testing, and that is our brass caps that sit on the ports that I take off to hook our tool up. And I've always said, anytime you have these off, you need to inspect them, because if you over tighten them, it fractures the top of the cap. This right here is the right-hand side cap, and we'll switch this over. And here's the cap I pulled off the left-hand side, and it is a perfect example of what I've talked about all these videos. You can see where it was over tightened, and the top of that cap is cracked and pushed right off on the top right there. So we need to get this cap replaced. Now this isn't a huge deal. It's not going to cause any big drivability issues. It's not really like a major failure, but it's just one of those things to keep an eye on, because it can cause a small little exhaust leak that we don't want. And since we have them off, we need to look at them. But also keep in mind, when you're putting these back on, just not a ton of pressure. Don't over tighten them, because you're going to pop these caps off. Fortunately, I keep these on hand, so that way I can always replace them when I encounter it, because it's semi-frequent and common. I will say that sometimes these just flat wear out, where they haven't been over tightened, but they've just been installed and removed so many times that finally just gives out and they crack, and this happens. So it's a common problem, but just one more thing to keep an eye on when you're working on and looking over these cars. I'm gonna go and continue the smoke test over here on the left-hand manifold, and if the manifold checks out good, then we'll move on to the next thing. If I find a leak, I'll bring you guys back and show you. But again, just like the right-hand side, we're gonna assume it's good, execute our check, continue on with the last few remaining checks we have on this car. And the verdict is the same over here on the left-hand side. We have the same leaks down there at our collector flange for our test pipe to the manifold. But up here where it really matters, we are good. So I was really inspecting around the perimeter where they crimp on the outside of the manifold, up along where the ends of it end on the head, and then right down here, which it's hard to tell, but the heat shielding ends a little bit before the collector. So I want to make sure that this smoke is coming out of the gasket and that junction, not up there on that collector. Everything looks good on that manifold, which is always good news on any car when all the manifolds pass this test, because the cost of new manifolds is a big expense, and really never good news when you find those on these cars. So with our smoke test behind us, the next thing on the agenda is actually going to be a 5-gas emissions test. We're actually going to use the Snap-on 5-gas emissions analyzer that I have right here on my lift. I'm actually going to use that hose and plug it right back into the same ports where we did our smoke test. Now, a lot of the cars of this era have these ports, and they're really great because they're before the catalytic converters. Granted, this car doesn't have any, but it's going to let me pull a raw, true reading from the emissions from both banks of the engine. On a V12 car, I'll be able to do it from the front 3 cylinders, the rear 3 cylinders for both banks. So 4 measuring points. On a V8, just 2 measuring points. So this gives us a good idea of really the health of the engine and the quality of the combustion burn that it has. It's just another data point that tells us how well or how healthy this engine is running, how well it's tuned. You know, if we have like a dead misfire or a partially plugged injector or anything like that, it's gonna show up in our emissions test. So I like to go through and gather this data. Also, when I do a service on a car, I do this emissions test anyways before I do the service, and then I do it at the tail end of the service, so that way we can compare the readings before and after the service. Now, because the car is cold, it's been sitting for a little bit, we're gonna have to fire it up, let it get warm, let it run for a little bit, so that way we can get the engine at its optimal, normal operating temperature before we pull the emissions to get an accurate measurement from there. So in the meantime, when the car is running, we're actually gonna come over here, and I have my SD1 interface box, and we're gonna get this all hooked up right here into our SD1 software. And on a 348, we really only have the option for our Motronic 2.7. There's really no other ECUs that we can get in there and interrogate and communicate with. We do have the 2 Motronics, which I have back behind the seat. You can see there is the passenger side, the right-hand Motronic, and there's one back here behind the driver's seat. I have the seat back so I can get into the car, but we'll go in. I have the key on right now, so we can go in and look at our faults. It should pull up both Motronics side by side, which is one thing I really like this SD1 for. So it's going to show our faults here. So we have a thermocouple ECU fault, engine speed sensor fault. You're going to see that every time. That's because the engine's not running. The Motronics are not smart enough to recognize that it does not have a crank signal because the crank's not moving. Once we fire the car up, that fault goes away. So we have a thermocouple ECU faults, but I did notice when I was looking over the car, the CAD ECUs are not installed. So I would expect to see those faults. That's not a huge worry, but I'm gonna come through and I document this stuff, and actually we'll come over, and as the car warms up, I also come through and capture our parameters screen. And the parameters is basically, you can see here, it tells me my load, my injection time, what the throttle angle is, which you'll notate. We have a fair discrepancy from bank to bank on that. My coolant temperature, airflow. It's pretty much all the sensor inputs to the Motronics. I can come in here and I will also capture that. I do that as part of the PPI, but again, this is the exact same thing I do pre-timing belt or major service. I capture all this information when the car's up to temperature and running, document it. That way on post-service, we can capture that information. And the goal is to always confirm that the car is running just as good or better than when it came in, being sure that when we send the car out the door, it's not in any way running worse than when we received it. I'm gonna let the car get warmed up, fire it up, just let it run. You can see I got the doors open. We're just gonna sit here and kind of watch my parameters. I'm gonna document that information. Then we'll come back, capture our emissions test. We'll get that. I do it at idle and at 3,000 RPM for both banks. So we're gonna get a total of 4 readings. We're gonna get that captured and we'll see what the results are. All right, so she's running, we're up the temperature. See, I moved everything around. I made a decision, since my throttle cable is so easy to act on here, that I have everything rearranged so I can watch my RPM with my SD1. I can get it to 3,000 RPM, and I can still reach my print button right here, so I just have them stuck on the side of the toolbox. That way I can be over here reaching with one arm and then hitting print on the other. So you can see I have it hooked up right now on bank 1. We're just reading it idle, and I'm just letting everything stabilize. I said this before in the past, I don't really scrutinize the numbers too much right now when the car is running. I wait till I'm done with the test, look at all the numbers at once and evaluate it and see what it's doing. When it's hooked up with the car, I really watch like my CO and my hydrocarbons. I watch those stabilize because those seem to have the most fidelity and move the quickest, which lets me know once it's stable, I'm getting an accurate reading. That's when I document and hit print and record that. So we're just gonna let that sit there. Everything looks pretty stabilized right now and doesn't really look too terrible, honestly. And we'll go and just hit print, and this is our idle reading. Once that's done printing, I'm gonna have to set you guys down so I can reach in, rev the car to 3,000 RPM, reach over, hit print, but I have to hold it at 3,000 so it stabilizes, and then hit print. If you have the car like oscillating, if it's like on its way up on revving or decelerating, that will change your emissions. So you wanna be sure that you do your best to hold it right at 3,000 to get that reading. Looks like we're done printing, so I'm gonna set you guys down, capture our 3,000 RPM reading. Well, we got one bank down, one more to go. Everything's moved over to bank 2. We got our hose on. We're gonna let it stabilize once again at idle. Easy to get the idle reading. We'll go back and do the same procedure to get our 3,000 RPM. Now we'll note that I'm holding the engine at 3,000 with the throttle bar where the cable bolts on here. I'm watching the SD1. I'm watching my RPM, and once I get it to right about 3,000, on that one it was about 2,900. I listen to the tone of the engine so that way I can break away, then look at my emissions tester, watch those numbers stabilize. I'll keep glancing at the SD1, but I'm actually doing more listening to make sure I keep the tone of the engine right where I want it. confirm that I haven't moved the RPM with the SD1, then reach over and hit print. And another tip, if you guys have a car running for a long time and you're using one of these emissions testers with these hose, even though they do have a water trap here, a lot of times you get moisture on the inside of that hose and it causes very erratic and unusual readings. So if you've been running for really more than 10-15 minutes, take the hose all the way off the car and blow compressed air through it. You'd be surprised by the amount of moisture that accumulates in that hose. You need to be sure there's no moisture in there so you get a good, accurate reading. We probably should be stabilized now at, ooh, our hydrocarbons here at idle is about double on bank 2 as it was on bank 1 at idle. We were, 324 hydrocarbons at idle on bank 1. We're at 563. So good information to have, and there could be a lot of reasons why that's the case. You know, with not having done a major service, this hasn't had one in 10 years. It needs spark plugs, the fuel injectors need to be cleaned. Who knows how good the fuel is? Who knows how the cam timing is? Who knows the health of the engine? There's a lot of reasons why. This is a mechanical lifter car. Who knows how good the valve adjustment is? Those are all things that we don't know yet. So there's not going to speculate too much on the emissions. We're just gathering data. We will have all of our data, then we start kind of piecing that puzzle together. All right, on to the last big check, and that's our compression test. So I do this in a specific sequence because I like to smoke test the exhaust when it's cold, not when it's warm, because you're more likely to see small leaks. For example, those leaks where we had at the junction for the test pipes to the headers, there's a good chance that if we were to re-smoke test it, now that the car is warm, that they more than likely might not be leaking. So that is definitely always my go-to on a cold engine. And then I'll warm it up, run my emissions test, do my scans. We need to get that stuff done anyways. And then we'll move into our compression test because I like to do that when the engine is warm. I don't like to run a compression test on a cold engine because it's not going to give us the truest and most accurate number. Now, speaking of truest and most accurate number, all right, I say this every time when I do a compression test. I'm probably always going to say it. I can't stress it enough. There's a couple key things that we need to do to be sure that we're getting accurate and consistent results throughout the entire test. Voltage. Not so much voltage, amperage. That's what you need to be thinking in terms of is amperage. I have my stabilized power supply on the car, so that puts out a constant 13.4 volts at 55 amps if needed. I do that because as we're cranking on the car, I don't want the battery to start to deplete on me by the time we get to the last of the cylinders, because then we're going to be cranking the engine over slower and we're going to have a different reading on our compression test. I want every cylinder that's getting tested on our compression to have the same battery supply, so that way our results are as consistent and close together and accurate as possible. The other thing that I love to preach about, which is keeping the throttle wide open. So I have my throttle prop rod there on the steering wheel, holding the throttle pedal wide open. I do this because it opens up the throttles. It allows the cylinders to get the maximum amount of air so you have a true compression reading, but also the plenums can have an effect from cylinder to cylinder if the throttles are closed. Because as you're cranking the car over, it's pulling a significant vacuum in the plenum, and depending on the airflow of the plenum, or say like a 355, on how well the throttles are synchronized, that will affect your compression test. Now, I found that out years ago doing a compression test, I think on a 308 with a carbureted 308, because the distance from that carburetor to the valve, there's really not even an intake manifold or runner. It's incredibly short. And the carburetor adjustment had a radical range or effect across the range on my compression test. So I did a compression test with the throttle shut. My numbers, not only were they low, they were all over the chart. And I'm like, man, this is weird. This car runs too good to have those numbers be true. I reran my tests with the throttles wide open. They're all dead nuts on. That right there proved that theory in my head. Every time I do a compression test, throttle wide open. The other thing I like to do, I have my start switch right here. So I have this hooked up to the starter signal, to the starter, and then to the battery. So we're only supplying a small amount of current to it. The starter cable is doing all the work, so there's not really a load coming through this. This allows me to bump the car over, free and clear, without having the ignition on. You can see that my key is turned off. I like to do that because that is the quickest and easiest way to get the car cranked over for a compression test and not worry about disabling anything for fuel or spark. Just quick, easy, down and dirty. I've already went through, removed the spark plugs. They are still plenty warm, so we're gonna let those cool down before I inspect them. Anytime I pull spark plugs out of a car, take pictures, I document them. Every time I take spark plugs out, they are all numbered so I know which cylinder they came from. Again, it's all, I think we're on a data gathering mission. That's what we're here for. So I got my notepad ready. Everything is set up. I just need to get my compression tester in there, run through and get the compression done, which reminds me, it just jumped in my head. I almost forgot one more thing that I really preach about on compression tests. Consistent number of cycles for each cylinder during the compression test. We want each cylinder to have the equal opportunity as all the other cylinders to show us what kind of compression it's building. So we don't want to crank one cylinder over 3 times and then the other one over 12 times and one over 15 because, again, consistency is what's important on getting this information. I usually count how many compression hits that one piston goes through as I'm doing the compression test, and you can hear the engine as it cycles kind of have that bump doing the compression test. I usually start on the first cylinder and I watch my gauge and I wait till the gauge basically maxes out, and then I usually give it 2 more cycles just to be sure it's good, and I usually count that number in my head, and that is the number that I'll do for each cylinder after that. Now, typically this has yielded me good results. It's usually around 12. And I'll run 12 cycles on one cylinder and I'll run through, and my readings are usually pretty consistent and I don't find anything that's wrong. And if I do have an unusual cylinder that is an outlier, I'll go back and maybe just run crank the car over and just see what its maximum compression is, no matter how far I crank it. But for my initial go around, I want everything to be equal opportunity. So consistent battery voltage all the way across the board, consistent airflow all the way across the board, and consistent amount of time to develop the same amount of compression. That's my goal. And if we have something that's unusual or doesn't match up, then we go back, investigate, spend a little bit more time, retest it. But for our initial surface level test, those are things that I always do on every car for a compression test. I mean, I don't know what to tell you guys. Over the years, I've had just things bite me where I start chasing something where I think there's a problem, and it came down to me being inaccurate during my compression test. So this is my current method on how I get it done. Wow, that one took 20 hits to stop building compression. That's 220 PSI, which is a fantastic result. We'll see where we're at across the board on the rest of these. But 20, that is more than usual. A lot more than usual. Be curious to see if I get the opportunity to do timing belts on this car and to find out where this cam timing is at. Because your cam timing will have a significant effect on your cranking compression. So it'll be interesting to see if bank 2 is equal and comparable to bank 1. I've had a few cars where there's actually a fairly good difference from bank 1 to bank 2 because the cam timing is different between the two banks. So do cylinder 2. Another strong one, 220. Cylinder 3. $225. Cylinder 4. $225. Cylinder 5. $220. I like what I see so far. Cylinder 6. $220. Cylinder 7. $220. And finally, cylinder 8. $220. Excellent results. Excellent. That was an outstanding compression test. 6 at 220 and 2 cylinders at 225. That is incredibly close. I'm very happy with that test. That is fantastic news. Our emissions test looked really good as well. So really this is looking like a very healthy engine. It just needs some routine maintenance, and this car is really, the list of needs is quite low. So here's my plan of attack. I am going to continue just looking over the car, compiling my notes. I'm probably going to go and speak with the client and see kind of what he thinks is the best direction for him with this car. Once I have that information and that conversation with the client, I'll probably bring you guys back, and then that's when we're going to come over the car. I'm going to show you kind of the ins and outs of the 348, what's different on this car from a 355, things that you need to look for in a 348, and what this 348 needs. But after I have that conversation with the client, I can give you guys some insight of what we're going to be doing in the future. So I got some paperwork to compile. I got a lot of notes to gather. I have a lot of pictures to take and get documented. You have to give me a couple days to get that information over to the client for us to hold our conversation. Once all of that is done, rest assured, I'll bring you guys back. We're going to crawl over this car, hit all the good talking points, and learn more about this beautiful 348. Welcome back. We are back on our 348 today. Now, it's actually been a couple weeks since we last were working on this car, but during that time, I had the chance to talk to the client about the condition of the car. More importantly, what we're going to be doing to this car, its needs. So here we are today, finishing up and recapping the condition of this 348, our inspection on this 348, and also I'll be able to tell you guys what we're going to be doing to this 348. Before we get into the scope of work that I'm going to be performing on this 348, let's go over the car, its conditions, its needs, and things that you want to look for on a 348. Now, I will say a lot of the things that I'm going to be talking about on this, I'm going to make comparisons to 355s. I like to note out some of the differences of a 348 to a 355 and also the similarities to them. So starting off, we have the car here off the lift, so we have ample space to walk around it. And really, the 348 is essentially the same chassis as the 355. They did do a lot of updates throughout the production run of the 348 and then thus into the 355. But the design philosophy, how it's designed, the removable rear subframe, I mean, a lot of the components are very similar. 355 bodywork's a little bit different. They kind of accentuated the hips back here in the back end, kind of made everything a little bit more voluptuous and bubbly and flared out as opposed to 348. And obviously on the 348, we have the strakes on the doors. One of the unique things about 348s that I actually love are the wheels. They are directional. These ones are installed correctly, thank goodness. And they are staggered for front to rear, but they have left and right. So it's 4 different wheels on this car. You can see by the design of the star and how it cuts in on the back side on the top of the wheel, right up here. And then if we come over to the other side of the car, you can see that the cuts are made. So there are 1 wheel per corner of the car. They have specific locations. Not a common thing on Ferraris, and I actually love that feature on these cars. I think it's super cool. Since I've had a chance to look over this car, guys, I gotta say that this one is actually in really, really nice shape for the mileage and age. It is a fantastic car. Paint's in good condition. Pretty much everything on the car is functional. This one is pretty well dialed in. So with this car being in such good condition, it's really a great candidate to talk about the things that you want to look for when you're looking over a 348. Now, on the exterior of the car, body-wise, there's really not a lot of things that are really specific to these cars that you need to keep an eye on. They're pretty solid cars, and a lot of the things that you're going to inspect during a regular inspection of any car are going to apply to a 355. So we're talking rock chips, blemishes in the paint, cracks, panel alignment. That's usually a good indication of a poor repair or a previous hit. So you want to look at how the hood aligns to the fender, the headlight bucket into the hood and the front fascia there, and compare them side to side. You can see this car is everything's lined up. It's very straight. The paint in it is great condition. There's no big rock chips, no big flaws. And that's all stuff you want to be looking for. Obviously glass condition, seal, all standard stuff. All those seals around the target top, the doors. You're going to want to check all those. Check down here. Now, these pieces are composites, so you want to check those for any cracks or blemishes or flaws. But where we start getting into some specific things for 355s and 348s is we want to start looking in this junction right here for signs of corrosion, where these 2 panels come down and intersect right where that black line is. And really, it's going to be back here. You're not going to see much of it on the door because there's not much on the upper part of the door, but it's the fender and the corner panels. You're going to want to inspect all that for any bubbling paint or corrosion. You don't want to inspect your fender lips here for the same thing, bubbling paint and corrosion. That's where the early signs of it start to show up. And the biggest problem with 348s and 355s is cracking back here on this sail panel or buttress. So there's a lot of paint cracking and checks and damages that happens there on cars. So you want to inspect all of that and make sure that that's in good shape. Or if the car you're looking at had a repair that it's been done properly and you don't see paint blend lines, you don't see previous body work underneath, everything looks good there. really, other than that, everything is pretty standard on these cars. They're pretty dialed in. You're going to want to go through, function test all your lights, check your bumpers, make sure your exhaust is lined up, all basic stuff. Really, not a lot of really specific things that really stand out on these cars that are coming to memory. They're pretty sorted on the outside. The buttress is the biggest thing. Check your front lip. Well, that's any Ferrari. Check the front lip, see if there's any scrapes or damage. A lot of steep driveways catch those and they cause damage. If there is, it's not a big deal. It's very typical for those to be damaged and then repaired. Short and sweet on the body. Not a lot to look for, a few key things. It's pretty short and sweet on the exterior of the car, so let's jump on the inside and go over the interior. As for the interiors of these cars, again, much like the exterior, they're actually pretty solid with not a lot of needs. The upholstery in this generation of cars, for some reason, doesn't lift and bubble at the same rate as the newer cars. It's actually pretty solid, but you're going to want to go through and check everything on your door panels. Really, where there's big concave pieces, that's where you want to check, make sure that nothing's starting to lift or bubble and come off. So you want to check that. Obviously, you're checking all your seats, everything for wear and tear, any wear on the bolsters, or signs that it's been corrected by a leather specialist that'll go through and do any re-dyeing, especially on the outer bolsters. As you can see, this car really outstanding condition with our interior and our seats. Again, wear on the steering wheel, all that, dash, same thing. Now, one thing about 348s is this is actually right in the era where Ferrari started to use the soft touch finish. Yes, the sticky items. Now, typically with 348s, there's not a lot of items that are actually covered with it, and honestly, these cars are so old that they've usually already been corrected and rectified if it did have anything that was sticky in it. So it's not as big as a concern on the 348s. 355 territory, that's when it gets real common. Everything's covered in it, and I still see a lot of cars come in with the sticky finish on things. So you want to go through and just check anything that's plastic to see if it has a sticky finish to it. And, you know, steering column trim, your vents, your upper vents, really anything that is exposed plastic in the car, check it, see if it's sticky. I make it a habit whenever I'm looking over the interior of any car to really just to run my hands along anything that is plastic just to feel it and see if it does have any sticky finish on it. So that way I can let the client know what items does have it, what may need a little attention, what is fine and doesn't need it. As for this car, it doesn't really have any needs when it comes to any sticky items or any upholstery rework that it needs for any lifting or bubbling. But on the inside of the car, there is a couple things that you want to pay attention to, and I will say specifically on 348s, you can have some problems with the climate control, and parts of these are really hard to get. So you want to be sure that you run through and test every function of your heater and climate control. Make sure your AC is working, which in this car, the AC was not working. It was not blowing very cold, but that could be a Freon issue, not a climate control issue. So a lot of issues I've had were actually with this ECU right here in the center stack, where these functions are not working at all and you can't change your vent positions. So you want to go through, check the operation of that. Naturally, you're going to want to test every button, check every gauge, function test everything, go in, even check your radio, make sure that works. All your gauges, stalks. Now on these older cars, there does develop issues with the turn signal stalks and the light switches where they start working intermittently. Those parts are pretty much not available. Your options are to find a good used set, or there are rebuilders out there that can refurbish your existing stalks. So that is somewhat of a common problem. But these cars are pretty reliable electronically, although they're pretty minimal with the electronics that they have in them. Another thing that's worth keeping an eye on when you're looking over these cars is your shifter gate itself, especially if it's an older car that has a lot of miles. Now this gate is actually what controls the location of the shifter when you're going in and out of gears. It is not just for looks. And a lot of times it's usually between 1 and 2. You'll see a lot of wear down here if the shifter is being run alongside this gate for a long time, and it actually will start to wear down the side of that gate, and it'll be very prominent because you'll see a worn point right there. If it gets worn too much, it can actually cause problems where you struggle to get the car out of one gear, through the gate, and into the next gear. I've actually encountered that where I was test driving a car, struggling to make like a 1-2 shift or a 2-3, I can't remember. And I started looking into it, and then I saw how wore the gate was. We ended up replacing the gate, and that corrected my problem. So what happens when that wears too much, it allows the shifter to go too far to where you're causing internal interference of the transmission because you're actually overextending the shifter as you're trying to shift it. So gate wear is not just cosmetic, it is something that's functional. Now I will say that I've probably only had that cause a problem on 2 cars that I've ever worked on. So a very rare and unusual problem, but it is a problem. Now, the other thing to talk about here in 348s is they have this sliding seatbelt system right here. And case in point in this car, they're not functioning. Now, a lot of people went through and deactivated those seatbelts. So I don't know if these ones have just been unplugged and they're deactivated, or if there's a problem and they're broken. So that's one of those things you're going to want to check these seatbelts, these sliding seatbelts. You know, a nice byproduct of the 80s and 90s where they slide up in the automatic seatbelts for you. Several Ferraris have them. They are a bit problematic. That's a lot of times why people disconnect them. They usually break. They don't want to go through and end up repairing them or put any money into them, or it just bothers them on the function of them, so they disable them. So you get a 348 without working seatbelts, it could be any of the above on why they're not functioning, why they're not working with the automatic function. Unfortunately, I don't have any good tips of say, hey, inspect this one component on those seatbelts, because I've seen them fail for pretty much every reason. But on top of that, you have people just deactivating them for any reason under the moon. So it's just one of those things that if your seatbelts aren't functioning, that you need to look into and see why. Case in point on this car, the automatic seatbelts are not functioning. However, I don't know why. I haven't looked into it. I don't know if they're just simply disabled or if there's a problem that needs diagnosed. That is just the reality of the situation. That pretty much covers the inside of these cars, gentlemen. There is not a ton of things to go over. They're pretty solid, pretty reliable. It's a true analog era Ferrari, so there's really just not a lot of things that fail that we need to notate. And on the inside of the cars, it's pretty much all cosmetic items. So let me get the car on the lift. We're going to get it up in the air, and then we can get a good look at our suspension, drivetrain, engine, transmission. Really, that's where the bulk of our inspection is going to be. I should have mentioned this at the beginning, but the 348 is a very unique car, not just because it's Ferrari's first unibody with a removable subframe, but because the car changed wildly depending on the market it went to. Now, we're not talking just if it's a US car versus a European car. It depended if these cars went into the European market, the configuration and how they are set up. Also, the early cars, which this one is, are quite a bit different than the later cars. Ferrari went through and made a lot of updates and changes to the cars throughout the production run. So what I'm trying to get to is almost every time you have a 348 in your stall and you're working on it, it's almost like a case study where you have to understand what car you have, what year it is, what market it was, and what the differences are on them. It's pretty unique because that is somewhat semi-typical of these cars in this era, especially if it's a European car versus a US car. But on 348s, they are, in my opinion, the worst I've seen on Ferraris. Like Testarossas, 308s, 328s, they're all pretty similar-ish, depending on the market, but 348s are like all over the map on the configurations. So back here at the engine, this is a F119D. That is the US spec engine. The European cars had the F119H, and the big difference that you can see on those cars is they actually have a much taller plenum on the upper halves. Those cars also have more compression, and the camshaft timing set a little bit differently, which we'll talk about that in a second. But those cars are actually rated at 320 horsepower versus our 300 here. So again, I have yet to see an H engine in person because it's mainly a European spec. This is the US spec car. I do know of a local car to me that is a European spec car, but I've not had a chance to see it in person yet to see if it does have the H engine with those taller plenums, because I would love to be able to drive one of these cars with the 320 horsepower variant to see how much different it drives over the 300. With that, the engine is the same basic essential engine that we had in the 328 and the 308. It's the same block. It's essentially the same block as the 355, except the heads are different. These are 4-valve heads. They're not hydraulic lifters. It has mechanical lifters. It is still fuel injected. So really a lot of the same thing. Obviously a timing belt car. The way our valve covers seal up is the same thing that we had with our 355 on the valve cover sealing up. Now I will say that since this is a 4-valve V8, these suffer from having the oil drain holes on the front of the cylinder heads where the cam caps and cam seal plates are being drilled in the wrong location from the factory. So there's an update where you need to use a special fixture, bolt it into the front of the engine, drill out those holes at the correct angle because they're drilled not at the bottom of the hole, so oil pools up and it causes oil to leak out of your cam seals. Very common problem, and believe it or not, I frequently still get cars pull the engine out and 20, 30 years later pull it apart and it has never been updated. So that is one thing you want to keep an eye on for those cars. The engine-wise, pretty reliable. A lot of gasket leaks, a lot of valve cover gasket leaks, cam cover gasket leaks we talked about. Same situation as the 355. I make the same modifications to my rails, file my edges so I don't pinch O-rings. It's the same style of sealing. same modifications that you can make to those to make them last a lot longer. But overall, the engines are pretty reliable, very robust. Manifolds, not really as much of a problem on 348s. I can't recall one time I found a bad manifold on a 348. I still go through and test them. I think I can attribute that to these cars don't make near the heat that a 355 does. A 355 just seems to generate a lot more heat back here, a lot more RPM, really pushing that engine a lot harder, and I think that's why those manifolds fail versus 348 that are pretty robust. You can see that we just have one air filter as opposed to the two air boxes on the 355. And you can also see that our oil tank is back here as opposed to a 355. It is tucked up kind of right behind the right-hand radiator. So that is a unique difference there. And then over here, we have our battery in the left rear corner of the car. And depending on your year, a 348, your battery could be in the front like a 355. So that is one of the things where they changed the battery location. And that's one of those things they tried to do to improve the handling of the car throughout the production run. Gearbox, it's still the same configuration that we have on a 355. It's a transverse gearbox. So all of our main shafts and lay shafts are running this way. You got a great view back here of our bell housing, our clutch, flywheels, all back here at the very back of the car. You can see our starter right there. Except the big difference is these are just 5 speeds, 355s are 6 speeds, but the philosophy, layout, everything is pretty much exactly the same. Our subframe is a bit different. Radiators, front of the engine on either side, so you can see that it is really exactly what you would think. It's an early version of a 355. Now, we don't have the heat shield here of the muffler, so that's why we have a good view of everything. This car is running test pipes, got our aftermarket exhaust. It has the same thing with our EGTs and CAT ECUs on the car. However, these ones have been removed. You don't need them if you don't have catalytic converters on the car. Now, another big change they did on the production run of these cars is the Motronic. Some of them, the early ones are a Bosch 2.5. The later ones are a Bosch 2.7. So that can also change depending on the car that you have. But really, 348s, they're actually pretty reliable, solid. So we all know one of the big Achilles heels in the 355 is the valve guides. However, these 348s, the 4 valve heads, are not as prone to having valve guide issues as the 355s. They can have those issues, but really not as typical. And that matches our findings on our compression test we did on this car with very high, consistent, even numbers. With the car in the air, let's start talking about the underside. And I guess we'll start back here with our flywheel and clutch. Just like the 355, these have a dual mass flywheel. They suffer the same problems with the grease breaking down, the flywheel starting to rattle. Same thing like a 355, you can take the flywheel apart, replace all the packing grease, replace the O-rings, get that taken care of with just some labor, minimal parts. As for the clutch on the 348, well, that depends what you have. Again, I was talking about the configuration. Some cars have twin plate clutches, some cars have single plate clutches, some cars have been swapped from one to the other. Now the clutches in the 348 reinforce what I was saying earlier on the configuration of the cars. Some cars have a twin plate clutch, some cars have a single plate clutch. A lot of people have swapped from twin to single, single to twin. You really never know, which makes it difficult to service these cars if you're anticipating a problem and trying to order parts ahead of time. It's one of those situations. 348s really, especially like a good example is the clutch. You just need to get the car torn down and pulled apart before you order parts. So that way you know what's in there and you know what your path forward is. It's really tough to be proactive with those. But you can look underneath here, and like I've shown on the channel, this looks strikingly similar to what you see on 355s. Pretty much the same configuration, just a little bit smaller since it's a 5-speed. And same thing under here, oil pan, everything looks pretty much similar. Now, big difference here is this is cable operated on our shifter as opposed to a 355 actually has a rod. But back here, things you want to look for, alternators. They are a weak point on 348s. They are pretty much undersized, so they work really hard. They fail pretty frequently. It's best to take them out and have them rebuilt. And if your rebuilder can up the output amperage on them, you're going to have a little bit of a longer life on the alternator, keep the same casing and body so it bolts back in. But I've seen and dealt with a lot of alternator issues over the years. Engine mounts, same thing, typical Ferrari, they do collapse. These ones do need to be replaced. They have started to sag and collapse quite a bit. And you can see here, same e-brake system as a 355. Again, the subframe looks virtually the same, although it is different back here. All of our suspension pickup points. And you can see that this car does have a fair amount of oil leaking on it, especially up here on our AC compressor. And that is from up above, coming from our valve covers and cam seals. So that is a very chronic problem. So that's just further proof of how difficult it is to get those valve covers to seal up and last for a long time. And while we're down here, it's worth talking about our cam sensors here, because I have been seeing a lot of these fail lately, not while in use, but more so when I'm working on the car, because all the plastic gets so brittle that if I have to touch it or move the connector, it just breaks and comes apart, and then there's issues. So that's just one of those things that's age related right there. Pretty common, and it's just one of the downsides of working on these older cars. You can see I still have the under tray, what little under tray the 348 has on right here, and our fuel tank is sitting right up above that. And we have all the floorboard of the car up here, and then again, we have more exposed stuff up here, like our control arm mounts, as opposed to a 355 because it has the aerodynamic under trays on it. You can see on this particular car, it's had the shocks rebuilt. The previous owner put tie rods on it. It has new ball joints. This car has really been sorted. I think he may have put wheel bearings in it. So the suspension wise, this car has been really well taken care of. You do want to check your control arm bushings, which they're hard to see up here on the front because they're in a pocket. We could probably get a better view on the rear. So you're going to want to check the rubber on those bushings and look for cracking. Now this is one of those really tough subjects, because pretty much any Ferrari, I don't really care what if it's a 456, 550, 355, 348, 328, they get old enough that rubber is going to dry out and crack. And I could say, yes, you have cracking suspension bushings, we should replace it. But if the car drives well, if it tracks well, if our tire wear is good and there's no adverse issues with driving the car with handling, I usually say we'll keep an eye on it and monitor it, because that's a lot of work and it's a pretty big job to go through and replace all of the suspension bushings on the car. That is definitely something you want to do and replace all of them, just not a few of them. So the bushings are cracking, but it's like an exterior crack. It's not cracked all the way through the bushing where the bushing has torn and rendered it useless. So a lot of people see that when I put it on my inspection notes that you have cracking bushings, but it doesn't mean the bushings have completely failed and they need to be replaced. I mean, they are failing, they are aging, they are deteriorating, but I usually am cautious on recommending that repair simply due to the cost and time it takes to do it. Really have to have good reason to do so. So that's where I wait for a symptom to really show up, where we might have unusual tire wear, we have trouble getting the car in alignment, maybe there's a clunk, maybe the car pulls. Once something like that starts to show up, then that's when we start having the conversation on when to replace those suspension bushings. The reality is I expect to find bushings in that condition on any Ferrari that I get in here that's 20, 30, 40 years old. So I always go through, carry the same conversation with the client, explain my point of view, and we assess each car and try to determine how severe that problem really is and when it is worth the time and money to go through and take care of that. Now, speaking of suspension, let's talk about that in a little bit more detail. The early 348s had less than ideal handling, and Ferrari actually went through and did a fair amount of updates on the cars through the years, where they actually added reinforcements to the frame for our suspension pickup points, so that way there's less deflection and movement in the suspension, trying to update it and make them handle quite a bit better. So there is an old bulletin, I believe it is 542, that talks about that update with all those parts that should be added in and welded onto the cars. Pretty much any car you see at this point is going to have that taken care of, but it is worth looking at, making sure you have all the updated pickup points installed. The last thing I wanted to cover while we're talking about suspension is the alignment settings. Now, when I was in dealer training, our instructor was a long career veteran of Ferrari, worked, I think, 25, 30 years at the factory when these cars were brand new. And we were specifically talking about the handling characteristics of 348s and the suspension settings. And he gave us some very specific suspension settings, which I have them noted down here, and I'm going to share it with you guys. I found it quite interesting. And he swore that if you set a 348 up with these alignment angles, that it would drive beautifully. But they're a little unconventional, because I usually like to keep everything pretty even. So I'm going to read you my notes on what he recommended and kind of what I jotted down through that experience. So he's saying to set the rear ride height to 125 millimeters. Set the front ride height to 120 to 125, not the specified 135 millimeters in the workshop. He says that's because there's so little air on the car, we want to be sure that we keep the nose down to keep the air from getting under the car and wanting to lift the car. Okay, that makes sense. Now he's saying camber is okay, do it by the book. All right, I'm good with that. Front toe, set it to 0. All right. Caster, set it to 7 degrees, not 5 degrees. I'm okay with that. I am a big fan of caster in my cars. Usually the more caster I can put in the car, the better. Although the 348's manual steering, you're going to increase your steering effort by adding that caster in. Rear toe, this is where it gets unusual. He wants a total of rear toe of 5 millimeters of rear toe, but he wants 1.5 on the left and 3.5 on the right. I found that unusual to stagger the toe that way, but he says that's going to compensate for road carrying and that really makes the car drive great. I'll be honest, I have not had a car where I've gone through and been able to try those settings on the car to see how well they work. So just take that with a grain of salt. I'm curious to see if it's the secret sauce that he says it is. I can tell you that I knew this instructor for my entire career while I was at Ferrari, and he never steered me wrong, and the amount of knowledge he had was incredible. So I definitely do take what he says pretty seriously and do believe it because, well, he had never steered me wrong, and he was a goldmine of information, especially this era of cars. He was a real treat to work with, lots of great stories. Any of the Ferrari technicians that are watching my channel know what instructor I'm talking about. So there's a quick recap on things to look for in a 348 and some of the common failure points and items, and also some of the differences to a 355. Now, I think the best way to describe a 348 is a much more simplified version of a 355, and they really don't have all the chronic problems that 355s have. You know, 355s suffer from failed catalytic converters. They have the flywheel rattle, which is shared from the 348, but not as common on 348s. But they have the valve guide issues. 348s, they're actually pretty robust. They don't have any of those issues. It's got manual steering. It's got the dogleg transmission, which I am a big fan of. It's got this virtually the same chassis. It's the same size of car, very similar looks. And it's just a much more simplified version of the 355. It doesn't have that adjustable suspension. A lot of those items are problems on 355s that you don't inherit if you have a 348. Now, if we compare a 348 through a 328, it's light years ahead. It's got a monocoque chassis with removable subframe. It's electronically fuel injected, not CIS injection. A lot better than 328s in my opinion. So they're a fantastic car. True analog Ferrari, right in the sweet spot with minimal electronics and a true driver's car. So how did our 348 fare from our inspection? Well, we know it's grossly overdue for a timing belt service. We know it has oil leaks. I found that it had some sagging engine mounts during the inspection. All of our suspension is good. Body-wise, the car is in excellent condition. Interior-wise, it's in excellent condition. Although, when we're going over the interior, I completely overlooked and forgot to mention the windows. Having the windows be slow to roll up is a very common problem on these older Ferraris, and it can be for a multitude of reasons. It can be an issue with the motor, the pulleys, the grease gets dry and tacky, slows everything down. It could be the switches, or it could be the wiring. It really could be anything. And this car does suffer in having both windows being very slow in operation when rolling up. Now, the client of this car actually has a window accelerator kit that's never been installed in the car that he provided with the car when he dropped it off. So since we already have those parts, that's probably going to be the first thing that I'm going to do to tackle those windows. I'm going to install that accelerator kit, reevaluate the window operation. Hopefully that takes care of it. If not, we're going to have to look a little bit deeper and see what the true cause of those slow windows are. But it's one of those things where I've seen pretty much everything cause a slow window. There's not one common problem. You just really need to get in there and take a peek at it. Since we already have those accelerators and they're pretty quick and easy to put in, I think that's going to be the first move that we do on this particular car. Now, as for the rest of the work on the car, well, I got the go-ahead from the client. We're diving in, we're taking care of the major service. We're taking care of those engine mounts. We're also gonna replace a leaking radiator, coolant hose kit, and just comb through the car and get everything sorted. Get this car dialed in, which is gonna be absolutely fantastic because this car is gonna be out on the market for one of you guys to enjoy. So that's enough talking for me. I need to get started on this major service. I just want to say thanks for watching. I appreciate your guys' support. You guys know the drill. Be sure to like, share, subscribe, drop a comment below, hit the hype button. As always, guys, we'll see you on the next one.